hear you perfect.
Hello, hi guys. So this is Jishan Ahmed Sheikh from India, and very grateful for GDG Ahlen to present this opportunity, and thankful to Anna as well. So what is this Google Cloud Arcade? Basically, Google does this marketing campaign twice a year, which is basically for enrolling students and developers to preach about their cloud services, bragging about their Google Cloud services and how does this help developers. So Google runs this campaign twice a year. The first part of this campaign is already over. The second part is still running. So in this campaign, what you do, Google teaches you about Google Cloud or any sort of cloud service from scratch. So basically, you're learning about cloud, you're learning about big data, you're learning about AML skills, Kubernetes, clustering, and all that stuff on Google Cloud. What happens is when you learn throughout these concepts, you perform simulations, you perform labs, complete courses, and in return of completing those courses, you're rewarded some points. Once you're completing some sort of quizzes, courses, and labs, the points which you acquire at the end of the campaign, you receive a particular Google Cloud swag kit. You can redeem your points in terms of the swags. So I'll present my screen and show you the exact page of this facilitator program. So basically, this program is a no-cost gaming campaign where you'll be learning about Google Cloud. You'll be about all sort of technical skills. Currently, we are here for professional ML engineer path certification. So all those skills are also inherited from this syllabus. If you come down over here on this official page, you'll see all those things train you for these professional certifications. So going through all those things also make you powerful enough to easily pass those certifications. So this is the program, and this is the point system of that program. If you complete 2 skill badges, you get 1 point, and at the end of the program, you can redeem your points in return for the swags. So this is this arcade program. Now, how do you get started? So currently the registrations are ongoing. You can enroll in the program by clicking over here, and then you'll be redirected to a Google form. This is officially by Google, by the way. So you have to fill this form with your details. You have to follow certain steps. So I am glad, I'm proud to announce that I am an official facilitator for this cohort. Google only selects limited 400 to 500 people across the cohorts. So I'll drop some links in the chat, which will redirect you to my community as well, which is also a partner community with GDG Ahlen. So you can join that community and you can ask me any doubt you have how to get started, and I'll guide you to the end of the program. So that's Google Cloud Arcade for you, and this is Arcade Ops community. And I am Jishan Ahmed, founder of Arcade Ops community. I, by profession, I am a CS engineer as well, similar to what Anna does, and I'm a very fond guy of this community events, hackathons, and I do a lot of collaborations as well. So I've dropped a WhatsApp link here, and if you guys are not habituated with WhatsApp, Anna will provide you the Discord links as well. And when it comes to connections, you can connect with me over here. I'll give you guys my LinkedIn as well. So here you. So that was me, and thank you to GDG Ahlen and Anna Muzikina for this wonderful opportunity. Looking forward to have some great ML engineers via
Thank
this
you,
program
Jay.
as well as.
Yes, thank you. And guys, believe me, Jishan very supportive. It's true. Sometimes I forgot that we are in very big, different time zones because you always answer on my. Sometimes I'm sure stupid questions in time. Yes, and last time when I took part at Arcade game, sometimes I get so strange issues, and you always support me. So feel free to join WhatsApp group. And why it's so important? Because main support, you will find exactly a chat group. Guys provide here all necessary resources, links, last news, etc. And of course, it's everything totally by free. They do this amazing job at their free time. I'm not sure, guys. You have not 24 hours a day, you have more. Because even today, when I open, I didn't visit this group a few days, and today, when I open, oh my God, near 200 messages. And when you have time to answer all of these messages. So, biggest thanks for your time. Biggest thanks for joining us today and sharing this interesting, useful, very helpful, and important activity. Believe me, it's help you to pass exams in future, because parts of these labs uh, are from a professional machine learning engineer. So, and meanwhile, waiting for our speaker. So our speaker today have internet issue. So this time, if you have any questions, let's discuss any questions you have. And waiting for our key speaker to continue diving deeper into professional machine learning engineer journey. And I hope everyone will hold motivation till the end, because it's 6 week journey. Yes, Kate, she is in Discord also. Yes. And at Discord, we try to share last news and questions. For example, last time I shared questions, exam question, and like try to make a wave in discussion. What do you think? What will be a correct question? A, B, C, or D? Yes, waiting for Kate. And thanks one more time for introduction of Arcada. And we are lucky because for now we are start professional machine learning engineer certification course, and a new wave of Arcada now is starting. So for now you have time. You have time to register to join this amazing very very supportive community, and combine your study with finishing necessary labs to get your gifts. And of course, not only gifts, not gifts main, knowledge, necessary knowledge. For example, last time when I get beige champion, and for now I waiting for gifts for champion, but main, I finished more than 400 labs. And of course now I inspect so deep Google platform. I never expected that I explore so deep. So for now we need to fix our speaker technical issue. So I'm so sorry for this. Let's try to connect. Let's continue to discuss fixing technical issue for our speaker. Okay. And if anyone today get any technical issues during joining this session, our speaker, she can join. So for now, we try to prepare another link for her. And yes, if you have any questions, feel free to share a Discord channel or here. And yes, I see at LinkedIn, I get few notification from new connections, and I accepted all of them. So biggest thanks. Yes, I see. Now we are friends, and feel free to share with me any your thoughts, ideas, everything you want. Oh, it's great. It's important for me to know that you hadn't any technical issues. Okay, so I see our speaker Kate join our session. Is perfect. Now just update your mode to moderator.
Just a moment, I will open presentation.
Okay, no problem. Don't worry. Okay, it's technical issues. Sometimes it's happened. It's okay. Yes. So today I had problems with internet connection, so sometimes it's happened.
Do you see my screen?
Yes, yes, yes. We can hear you. We can see your screen. Everything is perfect. Okay, let's continue.
So today we are going through certification journey. Um, we will um, identify our gaps and discuss our study. Today we will be speaking about data. We will review a portion of exam guide. You can see this. You can use this to organize your study. First section will be about ML program framing. The task is to identify the problems that ML can solve and understand what is needed to make it happen, how to measure success, and so on. Requirement analysis and implementation of ML solution and the pathway to future improvements. ML solution architecture. This section is more about designing reliable, scalable, highly available ML solutions by ensuring appropriate Google Cloud software and hardware products. We will architecture design that complies with regulatory and security concerns. And in section 3, we will talk about how to prepare and process data with a focus on preparing for your ML use case. And in section 4, we will talk about model development. This is traditional data science skills. It's about constructing a model and training it, then testing and deciding how to serve the model and actually use it in production. Section 5 is about step where we use model in production. So now we understand that data is the most important part of the ML. The accuracy of those predictions, however, depend on large volumes of data that is correct and free of errors. Low data is low quality, not aligned to the problem, or biased in some way, and it must be avoided in order to build successful ML models. There are 3 key stages to this learning process: data preparation, model training, and model serving. The first stage is data preparation, which includes 2 steps: data uploading and feature engineering. A model needs a large amount of data to learn from. Data used in machine learning can be either real-time streaming data or batch data, and it can be either structured or unstructured. The second stage is model training. The machine learning, it's where the machine learning starts its learning. A model needs a tremendous amount of iterative training. This is when training and evaluation form a cycle to train a model, then evaluate the model, and then train the data some more. The third and final stage is model serving. A model needs to actually be used in order to predict results. This is when the machine learning model is deployed, monitored, managed. If you don't move an ML model into production, it has no use and remains only the theoretical model. So it's not different from serving food in a restaurant. So if you compare these steps to running a restaurant, data preparation is when you prepare the raw ingredients. Model training is when your experience with different recipes, and model serving is when you finalize the menu to serve the meal to lots of hungry customers. Now it's important to note that an ML workflow isn't linear, it's iterative. For example, during model training, you may need to return to dig into the raw data and generate more useful features to fit the model. When monitoring the model during model serving, you might find data drifting or accuracy of your prediction might suddenly drop. You might need to check the data sources and adjust the model parameters accordingly. It turns out that the problem of finding the bottom can be divided into two different and important questions. The first is, which direction should you take? The answer involved the derivative. Let's say you start from the top left. You calculate the derivative of the cost function and find its negative. This means the angle of the slope is negative and you are at the left side of the curve. To get to the bottom, you must go down and right. Then at the point, you are on the right side of the curve and you calculate the derivative again. This time the value is positive and you must slide again to the left. You calculate the derivative of the cost function every time to decide which direction to take. Repeat this process according to gradient descent and you will eventually reach the original bottom. The second question in finding the bottom is what size should the steps be? The step size depends on the learning rate, which determines the learning speed of how fast bounce around to reach the bottom. Step size or learning rate is hyperparameter that is set before training. If the step size is too small, your training might take too long. If the step size is too large, you might bounce from wall to wall or even bounce out of the curve entirely without converging. When the step size is right, you're set. The seventh and last step is iteration. One complete pass of the training process from step 1 to step 6 is called an epoch. You can set the number of epochs as hyperparameter in training. Weights or parameters are adjusted until cost function reaches its optimum. You can tell the cost function has reached its optimum when the value stops decreasing, even after many iterations. This is how network learns. It iterates the learning by continuously adjusting weights to improve behavior until it reaches the best result. This is similar to a human learning lessons from the past. Learning about neural networks can be exciting, but it's also overwhelming with a large number of new terms. So let's take a moment to review them. Neural network weights and biases are parameters which are learned by the machine during training. You have no control of the parameters except to set the initial values. The number of layers and neurons, activation functions, learning rate, and epochs are hyperparameters which are decided by a human before training. The hyperparameters determine how a machine learns. For example, the learning rate decides how fast a machine learns, and the number of epochs defines how many times the learning iterates. Normally, data scientists choose hyperparameters and experiment with them to find the optimum combination. However, if you use tools like AutoML, it automatically selects the hyperparameters for you and saves you plenty of experiment time. Root mean square error. Root mean square error is the square root of average squared difference between the target and predicted values. RMSE is more sensitive to outliers than MIE. So if you're concerned about large errors, then RMSE can be a more useful metric to evaluate. MAA is termed from the statistic. Similar to MIE, a smaller value indicates a higher quality model. Null represents a perfect prediction. A confusion matrix. It's a specific performance measurement for machine learning classification problems. It's a table with combinations of predicted and actual values. To keep things simple, we assume the output includes only two classes. Let's explore an example. The first is true positive combination, which can be interpreted as the model predicted positive and that is true. The model predicted that this is an image of a cat and it actually is. The opposite of that is a true negative combination that can be interpreted as the model predicted negative and that's true. The model predicted that the dog is not a cat and that it actually is not a cat. Then there is a false positive combination, otherwise known as a type 1 error, which can be interpreted as the model predicted positive, that's false. The model predicted that a dog is a cat, but it actually isn't. Finally, there is the false negative combination, otherwise known as type 2 error, which can be interpreted as the model predicted negative and that's false. The model predicted that a cat is not a cat but actually is. A confusion matrix is a foundation for many other metrics used to evaluate the performance of machine learning model. Let's look at the two popular metrics, recall and precision, that you will encounter in the lab. Recall refers to all positive cases and looks at how many were predicted correctly. This means that recall is actual to the true positives divided by the sum of the true positive and false negatives. It's written in the formula. Precision refers to all cases predicted as positive and how many are actually positive. This means that prediction is equal to the true positives divided by the sum of the true positives and false positives. Imagine that you are fishing with a net. Using a wide net, you can catch both fish and rocks. 80 fish out of 100 total fish in the lake plus 80 rocks. The recall is this case is 80%, which is calculated by the number of fish caught, 80 divided by the total number of fish in the lake, 100. The precision is 50%, which is calculated by taking the number of fish caught, 80, and divided it by the number of fish and rocks collected, 160. Let's say you wanted to improve the precision, so you switched to a smaller net. This time you caught 20 fish and null rocks. The recall becomes 20%, 20 out of 100 fish collected, and precision becomes 100%, 20 out of 20 total fish and rocks collected. So once again, what recall and precision is. Just a minute. Precision and recall are often a trade-off. Depending on your use case, you might need to optimize one or the other. Consider a classification model where Gmail separates emails into two categories, spam and not spam. If the goal is to catch as many as possible spam emails, Gmail must want to prioritize recall. In contrast, if the goal is to only catch the messages that are definitely spam without blocking other emails, Gmail might want to prioritize precision. We can use the area under the curve as an aggregate measure of performance across all positive classification thresholds. Area under curve helps you to choose between models when you don't know what decision threshold is going to be ultimately used. It's like asking, if we pick a random positive and a random negative, what's the probability my model scores them in correct relative order? The nice thing about AUC is that its scale invariant and classification threshold invariant. People like to use it for those reasons. People sometimes also use AUC for the precision recall curve, or more currently, precision recall gain curves. We just use different combination of four prediction outcomes as metrics along the axis. However, treating this only as an aggregate measure can mask some effects. For example, a small improvement in AUC might come by doing a better job of ranking very unlikely negatives as even still yet more unlikely, which is fine but potentially not materially beneficial. Training and evaluating an ML model is an experience with finding the right generalizable model that fits your training data set but doesn't memorize it. As you see here, we have an overly simplistic linear model that doesn't fit the relationships in the data. You'll be able to see how bad this is immediately by looking at your loss metric during training. And visually on this graph here, as there are quite few points outside of the shape of the line. This is called underfitting. On the opposite end of the spectrum is overfitting, as shown on the right extreme. Here we greatly increased the complexity of our linear model and turned it into an nth order polynomial, which seems to model the training dataset really well, almost too well. This is where evaluation dataset comes in. You can use evaluation dataset to determine if model parameters are leading to overfitting. Overfitting or memorizing your training dataset can be far worse than having a model that only adequately fits your data. Somewhere in between an underfit where the loss metric is not low enough and an overfit whether the model doesn't generalize is the right level of model complexity. Let's look at how we can use our evaluation dataset to help us know when to stop training to prevent overfitting. Now, when we done training, how we tell our boss how well our model is doing. What data set do you use to do that final go or no go evaluation? Can you report the error on the validation data set? Actually, you can't. Why not? Because you use the evaluation dataset to choose when to stop the training. Remember, it is no longer independent. So, what do you have to do? Well, you actually have to split your data into three parts: training, validation, and a new completely isolated silo called test. Once your model has been trained and validated, you can then run it once against the independent test dataset. That is the loss metric you report to your boss. This metric you use to decide whether to use this model or not. Now, what happens if your model fails to perform against the test dataset even though it passes validation? It means that you cannot retest the same ML model and need to either create and train a brand new model or collect more data samples into your original dataset. It's far better for your model to fail in the final test than to fail after you have productionalized it. Well, this is a good approach. There is one little problem. No one likes to waste data. And it seems like that test data is essentially wasted. Can you use all the data in training and still get a reasonable indication of how well your model will perform? The compromise method is to do training validation split many times. Train and then continue the lost and then compute the loss on the validation dataset, keeping in mind this validation dataset consists of points were not used in the training this time, then split data again. Now your training data might include points that used in the validation in previous round. Train again and then compute the validation loss metric a second time. Finally, after new rounds of this, average all validation loss metrics. You will also get standard deviation of the validation loss metrics, which will give you a spread to analyze. This process is called bootstrapping or cross-validation. The upside is that you get to use all the data, but you have to train lots more time. So here's what you have to remember. If you have a lot of data, use the approach of having completely independent, held out test dataset. If you don't have much data, use cross-validation approach. But how do you go about actually splitting large datasets into these silos? This topic is for our next lesson on sampling. The idea is to penalize model complexity. So far, in our training process, we have been trying to minimize loss of the data given the model. We need to balance this against complexity of the model. Before we talk about how to measure model complexity, let's pause and understand why we set balance complexity against loss. The truth is that our simplified models are useless. If we make it too extreme, we will end up with a null model. We need to find the right balance between simplicity and accurate fitting of training data. Later, you will see that the complexity measure is multiplied by a lambda coefficient, which will allow to control our emphasis on a model simplicity. This takes us yet another hyperparameter that requires tuning. Optimal lambda value is for any given problem is data dependent, which means we almost always need to spend some time tuning this. ML needs some artful skills. Regularization is one of the major fields of research within machine learning. There are many published techniques and more to come. We already mentioned early stopping. We also started exploring the group of methods under the umbrella of parameter norm penalties. There is also dataset augmentation methods, noise robustness, sparse representations, and many more. In this module, we will have a closer look at L1 and L2 regularization methods from parameter norm penalties groups of techniques. But before we do that, let's quickly remind ourselves that what problem regularization is solving for us. Regularization refers to any technique that helps generalize a model. A generalized model performs well not just on training data, but also on never-seen test data. Most applications require database and storage solution of some kind. Google Cloud offers fully managed database and storage services. This includes cloud storage, cloud big table, cloud SQL, cloud spanner, Firestore, and BigQuery. How do you choose from these products and services? Well, it depends on the data type and business needs. Let's look at data type and which includes unstructured versus structured data. Unstructured data is information stored in a non-tabular form such as documents, images, audio files. Unstructured data is usually suited to cloud storage. Note that BigQuery now offers the capability to store unstructured data as well. Cloud storage has four primary storage classes. First is a standard storage. Standard storage is considered best for frequently accessed or hot data. It's also great for data that is stored for only brief periods of time. Listen carefully, maybe screenshot because the type of storage is widely used on the exam. So it's important to know it. The second storage class is nearline storage. It is best for storing infrequently accessed data, like reading or modifying data once per month or less on average. It's data backups, long-tail multimedia content, or data archiving. The third storage class is cold line storage. This is also a low-cost option for storing infrequently accessed data. However, as compared to nearline storage, cold line storage is meant for reading and modifying data at most once every 90 days. Fourth storage class is archive storage. This is lowest cost option used ideally for data archiving, online backup, disaster recovery. It's the best choice for data if you plan to access less than once a year because it has higher cost for data access and operations and 365-day minimum storage duration. Just a minute. There is structured data which represent information stored in tables, rows, and columns. Structured data comes in two types: transactional workloads and analytical workloads. Transactional workloads stem from online transaction processing systems, which are used when fast data inserts and updates are required to build row-based records. This is usually to maintain a system snapshot. They require relatively standardized queries that impact only few records. Then there are analytical workloads, which stem from online analytical processing systems, which are used when entire data sets need to be read. They often require complex queries, for example, aggregations. Once you've determined if the workload are transactional or analytical, you then need to identify whether the data will be accessed using SQL or not. So, if your data is transactional and you need to access it using SQL, then two options are Cloud SQL and Cloud Spanner. Cloud SQL works best for local to regional scalability, while Cloud Spanner works best to scale a database globally. If the transactional data will be accessed without SQL, Firestore might be the best option. Firestore is a transactional NoSQL document-oriented database. If you have analytical workloads that require SQL commands, SQL Query is likely the best option. SQL Query, Google's data warehouse solution, lets you analyze petabyte scale datasets. Big SQL Cloud Bigtable provides a scalable non-SQL solution for analytical workloads. It's best for real-time high-throughput applications that require only millisecond latency. The dataset IP will help you to create input functions for your model that will load data progressively. There are specialized dataset classes that can read data from text files like CSVs, TensorFlow records, or fixed length record files. Datasets can be created from different file formats. Use text line dataset for instantive to instantiate a dataset object which is comprised of lines from one or more text files. TF record dataset comprises records from one or more TF record files and TensorFlow, TensorFlow record files. And fixed length record dataset is a dataset object from fixed length records from one or more binary files. For anything else, you can use the generic dataset class and add your own decoding code. As the overall journey, each week we will review so let's cover the products available in each stage of the data to AI workflow. The first category is ingestion and process, which include products that are used to digest both real-time and batch data. The list includes PubSub Dataflow, Dataproc, and Cloud Data Fusion. The second product category is data storage. You'll recall from the earlier where there are 5 storage products. Cloud storage, which saves unstructured data as text, image, audio, and video. Cloud SQL, Cloud Spanner, Cloud Bigtable, and Firestore. Cloud SQL and Cloud Spanner are relational databases, while Cloud Bigtable and Firestore are NoSQL databases. Third product category is analytics. The major analytics tool is BigQuery, which you'll explore more later in this module. BigQuery is a fully managed data warehouse that can be used to analyze data through SQL commands. Also, you have BI or business intelligence tools to analyze data and visualize results. For example, Looker, which is a comprehensive BI tool. Looker offers different versions of its product, such as Looker for enterprise use, Looker Studio for individual use, And also there is AI and machine learning, which includes both AI development tools and AI solutions. These products are either integrated with generative AI or embedded with generative AI capabilities. The major product to support AI development is Vertex AI, which is an ungifted, which is unified platform and includes multiple tools such as AutoML, Vertex AI, Workbench, Colab, Generative AI Studio, Model Garden. Let's say our end objective is to build a model to predict the price of a house for a given set of inputs. What would you first want to know about the house? You might have said the square footage of a lot and the house, maybe the number of rooms. If it was sold in the past, what was it sold for? And you've probably already guessed that location could be a prime influencer of housing prices. It would be great if your raw data was already clean. Just the key fields you needed, as well as in a format you can just pass off to your ML model for training. It's almost never the case. Good feature engineering can take, on average, 50 to 75% of your time working with machine learning. It's critical you get it right. This example, there is raw data on houses on the left in the vector, which is to be mapped to the one or more fields in the proto on the right, which you can then use in your ML model training. It might be look like an easy mapping exercise to you, but how do you even know what a good feature is in the first place? Feature engineering can be defined as process what attempts to create additional relevant features from an existing raw features in the data and to increase the predictive power of learning algorithm. It can be defined as a process of combining domain knowledge, intuition, and data science skill set to create features that make the models train faster and provide more accurate predictions. Engineering features is primarily a manual, time-consuming task. The process involves brainstorming where you delve into the problem. So, what does it mean to delve into the problem? If your goal is to solve a problem where you need to predict an outcome and get the best possible results from a predictive model, you need to determine if your source data can aid in this goal. In other words, how can you get the most out of your data for predictive modeling? This is the problem that the process and the practice of feature engineering solves. So you start by looking at a lot of data. If you work as an academic researcher, you may have access to plenty of data source, from government data to industry data. If you work in a corporation, your data sources are the data your organization uses to manage the business. For example, you may be looking at the customer data, sales data, production data, inventory data, operational data. and this data could all be in different formats. The customer data could be in CSV file, the sales data could be from JSON file, the operational data could be in an XML format. So depending on your problem and your domain, you then need to leverage domain-specific engineering features. For example, if your machine learning problem is to predict seasonal sales based on a past customer purchase in a geographic location, then you must either have domain-specific knowledge or find domain-specific features to solve the problem. In this case, you may be looking for the data that allows you to create feature for customer purchases at a specific date time in a specific geographic location. Studying other features engineering problems highly recommended. For example, seasonal sales lends itself to time series features and longitude and latitude features. You then must devise your features. This can be done in several ways. In manual feature extraction, features are constructed manually. In this model, we use manual feature extraction. There we manually devise features using Python and TensorFlow libraries. Feature extraction is a process of dimensional reduction by which an initial set of raw data is reduced to more manageable groups for processing. For example, principal component analysis is a way to reduce a number of variables or features in your dataset. As the name states, you are simply analyzing the principal components to determine how well they predict your dependent variable or target, the final output that you are trying to predict. In technical terms, you want to reduce the dimension of your feature space. By reducing the dimension of your feature space, you have fewer relationships between variables to consider and you are less likely to fit your model. In automatic feature extraction, the idea is to automatically learn a set of features from a potentially noisy raw data that can be used in a supervised learning task such as in computer vision. You can also devise features using a combination of both automatic and manual methods. As you can see in this example here, the feature columns derived from the process can include numerical, categorical, bucketized, crossed, embedding, and hashed feature columns. The available preprocessing layers include text preprocessing, numerical features preprocessing, categorical features preprocessing, image preprocessing, and image data augmentation. Let's describe a few of them. You can use a variety of different layers to process categorical features. For example, Keras layers category encoding turns integer categorical features into one hot, multi-hot, or count-dense representations. This slide summarizes the different features engineering types that can be applied to features. So you can screenshot them. The scrolls, embedding, hashing, the so these questions I will put in chat later.
Yes, I think we can start discussing questions
No,
from
not
exam.
all.
From exam, yes, in Discord channel.
Yes. So also I want to tell you about feature store. Um, 3K challenges come up often for people working with ML features. Features are hard to share and reuse. Reliably serving in production with low latency is a challenge. Inadvertent screw in future values between training and serving is common. Feature Store is a fully managed solution. It manages and scales the underlying infrastructure for you, which means that your data scientists can focus on the feature computation logic instead of worrying about the challenges of deploying features into production. There is a lapse about feature store. For example, team can share and reuse ML features across use cases between feature store has a because feature store has a centralized feature repository with easy APIs to search and discover features, fetch them for training, serving, and manage permissions. The team can also serve ML features at scale with low latency because the operational overhead is handled by feature store. A common problem in machine learning is termed training service queue, which means the data you train with may be skewed or different from the data that is served in production. Feature store alleviates training service queue because it lets you compute feature values once and reuse them for both training and serving. You can also track and monitor for drift and other quality issues. Feature Store also allows for feature ingestion in large batches and or in real time as data streams in. So this Vertex feature store with Vertex AI feature store, the team can store features with batch and stream import APIs. These questions I also put in chat. Also, we have a homework for maybe you have a questions.
I think that we haven't any questions. We had just one question from Jimmy at Italian language, so he used Google Translator, but I answered his question. I guess. Okay, because thanks. Yes. And later, please duplicate at Discord channel homework with our attendees as well.
So the homework I put in chat and it will be also put in Discord channel.
Yes, and it will be two very interesting labs. So please feel free to finish these labs. It will be helpful in exams.
Yes.
From my side, I finished both of them. It was
It's
not
also
super hard. It was interesting and easy labs. So feel free to finish them, please. And of course, questions, uh, examples of questions which you can meet at your exam. Kate will share at our Discord channel. So, Kate, I started place questions. I guess I created a sample questions chat channel, and here I started share questions, and I share just questions without correct answer, just motivating attendees to discuss. So what do you think? What will be a correct
yes, please,
answer?
guys.
Yes.
Answer. Don't be shy.
Yes, yes.
Discuss.
Same here from your side. Just share questions and let's imagine what can be correct. A, B, C, or D. Any your idea, no matter it's correct or it's wrong. It's our space for studying, for exploring, for discussing. Uh, Errors and mistakes, it's our helps. If we are in mistake, it means that we have where to grow up. It means that we have where to find correct answer. So it's a it's space where no one tell no why you are right wrong answer. No, 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 it's okay to be in mistake. It's okay. So this
Also,
session was recorded. Yes, yes, Tobias. Yes, a new round of homework. Yes, two laps. Feel free to finish. Believe me, it's very interesting labs. I finished all of them. It's really interesting, exciting, and not too harsh. No, not too hard.
you
And
can
of course,
ask
keep
us
shares.
questions in this Discord.
Uh,
Don't be shy. Nobody writes there.
yes, of course. Our Discord channel is our space for discussion. Any your ideas, no matter it's wrong or correct, it's our space to discuss, to help each other. Our goal to support, to motivate, and we haven't any goal to tell you, oh no, you are in mistake. What are you doing here with such opinion? Of course, no. Of course, no.
Also, you could sign up for Google Cloud Innovators. They have 35 monthly credits for your labs. You
Oh,
have
Kate,
now,
Kate, I remember that you told about some free course for machine learning today. We
just a moment.
can you yes, is it
I will
possible for you to share this exciting news? Exciting news.
Mm, there are two courses on Udemy for free, just couple of days free. Just a minute, I will share it.
Our goal is we never promote anything. No, we never motivate you by anything. No, no, no. We never advertise anything. Everything we share is totally by free. We haven't. Our goal. We are volunteers. We didn't make money on advertising anything.
So sign
Game,
up
Udemy
until
course. Yeah,
sign
totally.
up until coupon is working like couple of days and it will be free for you. And then you can learn or maybe you can learn in future. Just now it's free.
Perfect. I'll share this and the description of recorded video.
Also, I can talk about exam. If you failed, you can do the next round of exam to sign up in 50 days. In 15 days, that will be the second round. And if you failed again, then you can sign up for the same exam in 60 days. And if you failed again, the fourth round will be you have to wait a year and then sign up. So, but I wish you all the good, and I wish you pass the exam. Just keep in mind that if you want to retake this exam, you have cool off period. Yes, that's all. So what I like about Google Cloud exams that you can eat and drink them.
During
I
exam.
haven't seen such privilege anywhere else. It's great.
So, okay. So we haven't any questions. Okay, let's continue in our Discord channel. Kate, biggest thanks for your time. Biggest thanks for your talk. Waiting for simple questions in Discord channel, and let's discuss questions because exactly these questions you will meet during exam session. So let's discuss here. And please duplicate a Discord channel homework. I'll repeat homework under description. Okay, link to Discord channel. I was sure that everyone has this link. Okay, if someone skipped last talk, if someone skipped my emails because after last session I sent email to everyone who was registered with Discord channel link, and of course I play this link under recorded video from last session. But if you skipped, you're welcome. I shared one more time Discord channel. And please feel free to share a Discord channel any your questions, ideas, worries, I don't know, anything you feel you want to share, feel free to share. And here we try to discuss questions which we can met during our exams, and we share it here homework. Homework is just labs necessary to finish, because exactly these labs help you to prepare for exams. So feel free to join our Discord channel. And Kate, one more time, biggest thanks for your time. So I think that we
Thank you.
haven't. Yes, yes. So I think that our session. So we discussed everything we want to discuss.